Some headers have a straightener with a power starter. It may be mounted on the back of the header or on the back of the wire drawer. This one has been set up to be used only as a power starter. These three rolls are the wire straightener rolls. Wire is straightened by the downward pressure of the top middle roll onto the two outside bottom rolls. The bottom right roll assists in both wire straightening and wire starting. The bottom middle roll is the guide roll. The guide roll has a wider groove than the other rolls. This is the power starter roll. The power starter roll is used only to help load and unload large diameter wires during setup. It is driven by the power starter motor. This is a power starter motor. The power starter motor is controlled by the straightener forward and straightener reverse push buttons. This is the air control handle for the power starter roll clamp. It engages and disengages the starter roll to the wire. The two middle rolls are mounted on a slide which allows them to be adjusted up and down together. The purpose of this slide is to adjust the rolls up or down to increase or decrease wire straightener pressure. This is the straightener adjusting screw nut. Turning the adjusting screw nut clockwise will increase straightening pressure. Turning the adjusting screw nut counterclockwise will decrease the straightening pressure. The rolls have grooves which must be properly sized to the wire. The rolls must be changed to fit the diameter of the wire being used. The rolls are stamped or marked for the wire diameter with which they can be used. You will need to check your layout sheet to select the correct size. Setting up the rollers for a new job begins by raising the power feed roll using the air control lever for the power starter roll clamp. Before installing the new dies, the punches should be removed from their holders. To remove a punch, loosen a draw bolt and remove the punch from the punch holder. On Boltmakers, the trim die is mounted in the tool holder on the heading slide toward the operator's side of the machine. To remove the trim die, you must also loosen the draw bolt and disconnect the air line on the bottom of the die. Select packing and shims for each new die stack so that it equals the height of the old die stack. This will ensure that each new die assembly will be flush with the die block when installed. When preparing the shims and packing, the best rule to follow is to always use the largest size packing and the fewest possible shims. The kickout pin must be installed in the die. If a pre-cut kickout pin is provided, lubricate it before you install it into the die. If the kickout pin is not pre-cut, you will have to make one out of the correct diameter tool steel. To determine the length of the kickout pin for a particular die, measure the length of the die, packing, shims, and the pin guide. The kickout pin in the first die should be about 15 thousandths longer than the kickout pin in the second die. The second die kickout pin should also be about 15 thousandths longer than the kickout pin in the third die, and so on across the die block. This is called the transfer clearance. Since the kickout pin in the next die is always shorter, it allows clearance between the end of the blank and the end of the next die's kickout pin. Without the clearance, they may make contact, causing the blank to drop or causing damage to the transfer fingers themselves. The trimming kickout pin must be recessed in the trim punch, and therefore its length will not affect transfer. Now let's look at transfer timing. The timing of the transfer fingers must be adjusted on systems operated by both finger cams and tappet levers. Remember, on the forward stroke, the fingers must remain closed long enough to allow the punches to make contact with the blank and begin to control the blank. The fingers then must open soon enough to avoid being struck by the punches. The closing of the fingers on the return stroke must be timed to occur as late as possible in the machine cycle. This will reduce finger wear caused by pushing blanks through fingers that have closed too early. Tappet lever operated transfers have a single cam that times the opening and closing of the fingers. The transfer cam is located behind this cover on the operator side of the machine. The open timing can be set for long or short parts. Longer parts would enable the fingers to open sooner than shorter parts. To adjust open timing, loosen slightly the two closed lock nuts. Be careful not to loosen the one on the right too much. The close adjusting plate must stay locked into the serrations on the drum surface during the adjustments made to the open timing. Now, loosen the open cam lock nut. Turn the open cam adjusting bolt to move the cam lock nut in the desired direction. To cause the fingers to open later, move the lock nut clockwise. This is for shorter parts. Move the lock nut counterclockwise to open the fingers sooner with longer parts. Tighten all lock nuts securely. Jog the header forward to check your adjustment. To check close timing, the feed must be on so that blanks are fed and kicked from the dies. To adjust the close timing, loosen the two close lock nuts enough to allow the close adjusting plate to be free from the serrations. Move the plate clockwise if you want them to close later in the kick-out stroke. Move the lock nut counterclockwise if you want the fingers to close sooner. Tighten all lock nuts and jog the header to check your adjustment. The next adjustment is called die match. Matching the dies means aligning the dies vertically until the thread forms of the two dies line up. Begin die match by jogging the machine until the movable die is at the end of its return stroke. Now position a blank in the dies. Jog the machine until the blank has made 1/2 of one revolution. Place a mark on the top of the blank on the stationary die side. Now slowly jog the machine in reverse and remove the blank. You will see two sets of grooves on the blank. The grooves will be aligned if the dies are matched. Dies that are not matched will produce grooves which are not aligned. The grooves made by the movable die will be to the left of the mark you made on the head of the blank. To adjust the height of the stationary die, first loosen the lock nut on the bottom adjustment wedge nut. To raise the stationary die, turn the adjustment wedge nut counterclockwise. Turn the nut clockwise to lower the die. Jog another blank through the dies and check your adjustment. Repeat this procedure until the dies are matched. Do not tighten the lock nut or the 3 stationary die clamp bolts. You will need to make further adjustments after the handling parts have been set up. The next step is to determine the correct pusher to use. To do this, you must consider blank length, pitch diameter, thread length, and any special features such as a shoulder. First, check blank length. The pusher must apply even pressure along the body of the blank. Next, check pitch diameter. The thickness of the pusher should be slightly less than the pitch diameter. If it is greater, the pusher will not fit between the dies. Now check thread length. The top of the pusher will be flush with the top of the dies. This is a good gauge to determine if the pusher tip is the correct height. Now check for special features. For example, the pusher should not contact the shoulder of a blank. This will tip the blank and result in irregular threads. To replace the pusher, begin by jogging the machine.